Welcome to today's tutorial about virtual functions. It is one of the fundamental concepts is polymorphism, which allows objects of different classes to be treated interchangeably. C++ provides powerful tools to achieve polymorphism, and one of them is the virtual function. A virtual function is a member function declared in a base class and overridden in its derived classes. The keyword virtual precedes the function declaration in the base class, indicating that the function can be overridden by derived classes. When a virtual function is called through a base class pointer or reference, the actual function called is determined at runtime based on the type of the object being pointed to or referred to. To declare a virtual function, we use the virtual keyword before the return type in the function declaration within the base class. The virtual keyword informs the compiler that the function can be overridden by derived classes. It establishes a link between the base class and the derived class, ensuring the correct function is invoked based on the object's type. To override a virtual function in a derived class, we use the same function signature as the base class. The override keyword can be added to the derived class function declaration to improve code readability and prevent accidental errors. When a virtual function is overridden in a derived class, the base class function is replaced by the derived class function in the object's vtable. The primary benefit of using virtual functions is to achieve polymorphic behavior. Consider a scenario where you have a base class called shape and derived classes such as circle, rectangle, and triangle. Each derived class has its own implementation of a common function, let's say calculate area. By declaring calculate area as a virtual function in the shape class and overriding it in the derived classes, you can call calculate area on any object of type shape, and the appropriate implementation will be invoked based on the actual object's type. Here's a simplified example to illustrate this concept. In the above example, the calculateArea function is declared as virtual in the shape class and overridden in both the circle and rectangle classes. By calling the calculateArea function through the base class pointer shape ptr, the appropriate implementation is invoked based on the actual object's type. This allows us to treat different derived class objects uniformly through the base class interface. Let's go through another example of virtual function.
In this example, we have a base class animal and two derived classes dog and cat. Each class overrides the makeSound function, which is declared as virtual in the animal class. In the main function, We create objects of dog and cat classes. We then assign the addresses of these objects to a pointer of type animal. When we call the makeSound function through the base class pointer, the appropriate implementation is invoked based on the actual object's type. Now see how virtual functions work. Each class that intends to use virtual functions must have a virtual function table or vtable associated with it. The vtable contains function pointers to the virtual functions of the class. When a virtual function is called, the appropriate function to execute is determined based on the actual object type at runtime using the vtable. This concludes today's tutorial. Feel free to ask any queries you may have about virtual functions or related topics. Thanks for watching. Please subscribe the channel.